Hi, my name's Callie. I'm a rising senior at the Dalton School, and my starter project was a piano. I can turn it on. So to demo the piano a little bit, I can turn it on, and this LED signifies that it's on and it's ready to play. Play a couple notes, and additionally there's another feature where if you press this button, it'll play this lovely song, and then you can turn it off once it gets annoying. So the key parts of the piano are the batteries, the speaker, this potentiometer, the button of course, the IC chip, which is where all the logic happens, all these buttons, and the resistors, and these capacitors. So obviously the batteries power the circuit. These LEDs, this turns on when the circuit is running, this turns on to let me know that it's ready to play. The potentiometer allows one to adjust the octave. So to demo the potentiometer, can play B, but you can also play it very low, and you can also play it very high. So these capacitive sensors are really important. They don't actually have any capacitors in them, but they're called capacitive sensors because they kind of look like capacitors. As a reminder, capacitors have two plates and then there's an electrical field in between. But these, for these sensors, one of the plates is the key, the other plate is one's finger, and the space between them is the electrical field. And so the capacitive sensors basically sense if you are touching them. And that sense is then goes through the resistors, and those are really, really big, 2 million ohms each, which filters out any oscillation from any difference in pressure that you're touching the capacitor with. Additionally, to filter out even more oscillation, five readings are taken from the resistor at any given point, and then the average is taken to see if the button is being pressed or if it's just a fluke. Finally, these capacitors are really important because they are sort of charged by the battery. A capacitor is two plates and then there's an electrical field in between, and when the battery charges the capacitor, it sort of puts electrons in between them. But the capacitor can decharge itself really quickly, so it can just take all the electrons and put those into current, which allows a really fast tone to be played. When a tone is played, it's only played for like 30 milliseconds, so all that energy can just come from the capacitor. It's really efficient. As for challenges I had for this project, the first one was that these clips weren't actually touching the battery, so everything was soldered in and nothing worked because there was no conductivity from the battery to the whole circuit. Additionally, at the back, my circuit board got fried, and so there was no connection between the batteries, but that was solved. But everything else was pretty understandable for me, because I was at Blue Stamp last summer and I learned a lot about Arduino. So reading the code that makes this work was like pretty understandable and familiar. And additionally, through my comp sci at school and physics at school, I know a reasonable amount about the code and also just the circuits as well.